Hello, I'm going to demonstrate you how to use the Easy Java simulation software to model a simple pendulum. First, go to the directory where your Easy Java simulation is installed and start it. Uh, there are three steps how to produce your model. First, description, where you can generate a page that describes your model. The second step is the model itself, and the final third step is visualization of your model. So let's skip the description page and go directly to the model page. So I choose the model page. The first step in modeling is to specify variables here. So click to create page of variables. Let's call them state variables. Okay. So now we have an angle A. Let its initial value be 0.5 radians. The second state variable is the rate of change of the angle with time, say at. Let its initial value be 0. We also have time as an independent variable. Time initial value is 0, and we also use dt, the first time step. Let it be small enough, say 0.01 second. So we delete the last string that we don't need. So now let's check. We have the angle, the rate of change of the angle, the time, and the first time step 100th of a second. So next step, we should introduce our differential equation. So this is done at the evolution step. So we want to click this area to create a page of ordinary differential equations. Okay, so let's call it let's just call it ODE, ordinary differential equations. Okay, so now first we have to specify our independent variable so that the program knows what we use for it, t time. So now the first equation, the rate of change of angle, so therefore it's a. So we have dA over dt, so the rate of change of angle, and it is just at. So this software actually can solve a system of first order differential equations. Therefore, for the second order differential equation, we have to use a system of first order equations. We have in this case two equations. The second state variable is the rate of change at. Okay, and for it, for a simple pendulum, we have minus g divided by L. G is the gravitational acceleration, capital L is the length of the string, times math sine angle of angle A. Okay, sinus of angle A. Okay, we don't need the last string, remove. Yeah, and we forgot, by the way, to specify our constant gravitational acceleration, the length of the string. So let's go back to variables, and we need one more page. So therefore, we use the right mouse button. Then in the pop-up window, we choose create a new page. We choose the name for this page, say parameters, which will include the gravitational acceleration and the length of the string. So now g is our gravitational acceleration, its initial value 9.8, and the second parameter is capital L, which is the length of the string. Let's use for it just 1. Okay, again we don't need this last row. Okay, so now we have state variables, parameters GL, and we have differential equations that describe how our angle A and its rate of change with time. So these are a system of two first-order ordinary differential equations. Okay. So now we want, and in this window, the software automatically chooses reasonable values for other parameters. For instance, frames per second, how frequently it will change, it will renew the output data. Okay, there is also possibility to choose the solver. We'll use the automatically chosen solver and tolerance. Okay, let's don't change these parameters. Now we want to visualize the solution of this differential equation. Therefore, we go to the final third step, view. Okay, so now we choose first the frame, which is a top level window. Okay, we added here just frame. Okay, this is the frame. Okay, we can also have a look at parameters of any view element by using the right mouse button and checking the properties. Okay, these are the properties of our frame. Okay, so now we want to put in this frame an animation as well as some control buttons. So therefore, let's first specify the animation. Therefore, we choose this icon, which is drawing panel for 2D animation. Okay, let's add it to the frame. Drawing panel. Okay, center. Okay, so now this is our drawing panel. Let's use right mouse button, click and check properties. So these are properties. Okay, let's change these parameters. So we want our animation window to have coordinates from minimum x minus 1 to maximum x plus 1. It's okay. But I wanna change minimum y from minus 0.5 and maximum y coordinate to plus 1.5. And I also that the area of animation be a true square. Therefore, I just choose true. Okay, now it will be a true square. That's it. Okay. So now I want to put some visual elements into this animation window. So first I need ceiling, a point to which my pendulum will be attached. So I choose this shape to the shape. Okay, I add it to the drawing panel. I call it ceiling. Okay, ceiling. Okay, so this is ceiling. So far it's in the wrong position. I want it to be somewhere here. Therefore, I go to ceiling, choose right button of my mouse, properties. So I want to change position of this ceiling. Let it be in position x0 and position y at L. Capital L is the length of the string. Okay, I also want to have this ball to be of a smaller size. Therefore, I specified size like 0.05 x size and 0.05 y size. Is it okay now? Yeah, it's a small ball to which the string with pendulum bob will be attached. So now I need To add the bob of my pendulum, I chose the same object, a graphical object, and I add it to my drawing panel. I say this is bob. Okay. Okay, let's use different colors. Let's say I want the bob properties be of red color, fill color red. Okay. Position. Okay. Position X. So X position should be L times math sine of A. Position Y should be L times 1 minus math dot cosine of A. Okay, so let's check. Yeah, it's in a position that corresponds to the initial angle A, which is 0.5. Okay, so now I need to connect ceiling with the bob with a string. So therefore I choose here this segment. I add it to my drawing panel. Let it has a name, just let it have a name, just segment. Okay. Now I specify properties of this string. So position should correspond to the position of the ceiling. Therefore, it's x0 and y capital L. And size. When I add size to position, so it's to position, I should get the position of the bob, right? So therefore, size x should be L times math dot sine of A, and size y should be minus L times math cosine of A. Okay, let's check. Yeah, so now the ceiling and the bob are connected by this segment, by this string. So it's almost done. Okay, so in order to check if it works, I should go to this green triangle, which should run simulations. I should click on it. Okay, first the software asks me to save my simulation. I go to users. This is my directory. So let me call it this simulation my pendulum. Say my pendulum. Okay, save. Okay, now I see the code has been collected, compiled, and now I see that my pendulum is swings, so it's swinging. So okay, so now to stop it, to stop the simulation, I go back to the place where this green triangle was. Now I have this red button. I click it, so and I back to the simulation stage. Okay, so now I want to add some controls to my simulation. So therefore I go to this button, which shows what this buttons and decorations. Okay, so first I choose this button, to state button, just to have possibility to pause and resume my simulation. I add it to the drawing. Okay, so first I have to add panel, this panel that which will contain my controls. Okay, to the frame, to the this. To this frame. Okay, so I add controls. I call it controls. Okay, controls. Okay, let's done. Okay. No, I think I should delete it. I think I should add it to this drawing. Okay, controls. Not to the frame, but okay. Down. Okay. yeah, it's here now. Now I choose this control buttons, which is this one. This one is two-state button. Okay, I add two controls, and I call it say play and pause button. Okay, okay, center. So this is my play pause button. I want to specify its properties. Therefore, right-click properties. Okay, variable is post. What I should specify action on and action off. So on action on it's play, on action off it's pause. So everything is already done automatically. So let's check. You see there is button play added. To check if it works, I go. I run the simulation clicking by this green triangle. Okay. Yeah, it works. This is pause. It's paused. Click again. Play. Pause. Play. Okay, pause. Now I turn off my simulation, and now I want to add two more buttons. Okay, control buttons. First, this button, a button for actions. I want to be able to reset my simulations. I added two controls. This is will be reset button. Reset button. Okay. Sit down. Okay. So this is my reset button. Right click properties. Reset button action. I want action reset. So underscore reset. Don't forget parentheses. Okay. So now I have reset. Oh, I don't need reset button. Just reset. Okay. Reset. Just reset. Okay, reset. Now let's try run simulation. Okay, play. Okay, my simulation is running. Okay, it says here that I made an error. Instead of underscore, I used minus here. So therefore, I go to reset button, right click properties here. Instead of a dash minus, I should use underscore. Okay. So now run. Okay. Pause, and when I click reset, it goes from the beginning, from the initial conditions. Pause, reset, pause, etc. Stop simulations. Now I want to also add a possibility, say, to change one of my parameters, for instance, gravitational acceleration. Therefore, I choose here this icon, which is slider, so I can smoothly change the gravitational acceleration. I add the controls. I call it, say, J slider. J slider. Okay. Okay. This is J slider. Right click properties. Which variable? G gravitational acceleration. From minimum, let's say from 1 meters per square second to say 20. Okay. And format of data will be doesn't matter dot 0 like this. Okay. Okay, so now I have this slider. Let's check if it works again. Green button. Yeah, it works. Let's try to change gravitational acceleration. It's strong acceleration. The frequency of the pendulum increases, and small acceleration. The frequency of pendulum decreases. I can pause, play, pause. I can reset to initial conditions, and I can smoothly change gravitational acceleration. This number shows 10, 9, 7, 4, small acceleration, high acceleration, pause, reset, okay, pause. So that's it. Then the final step, which I can do, I can use this button. First, I should stop simulation, and now I can use this button to package my simulation. So I click it. It will be packaged into a file, a Java file, which can be run on any operational system independently. So EGS mypendulum.jar. Okay, save. So now I'm done. So I yes, I exit easy Java simulation software. And now I go to the directory exports where my package was saved, and I can run it independently. Java minus jar. Okay. And this, yeah, let's try. Okay, so now it's the simulation is independent of the simulation software, so I can use it. I can distribute it. Pause, set, play, pause. Okay, that's it.